Welcome. In this video, we will build the local OpenKubes environment from a clean Mac host. The goal is not to install platform applications yet. We will focus only on the foundation, two separate multipass virtual machines, each running in its own separate K3s cluster. One cluster represents the management layer and the other one represents the workload layer. By the end, both nodes will report ready, and we will have separate kubeconfigs and SSH tunnels for reliable access from the host. This separation is intentional. It makes the local environment resemble the production responsibility split while keeping the setup small enough for development and learning. The most important concept is the responsibility split. OK Management Local is the management cluster. It is where platform control components will live in later tutorials. OK Infra Local is the workload cluster. It is where application and infrastructure workloads will run. Both are independent K3s servers inside a separate multipass VMs. The management cluster does not run the workload cluster as a child process. It manages it through Kubernetes APIs and provider credentials in later steps. For this video, we will only establish the two healthy endpoints. Keeping the roles separate also helps us explain why the kubeconfig, tunnel ports, and verification commands are different. Before we clone the repository, verify the host tools. Git retrieves the project. Make provides the documented command surface. Multipass creates and manages the Ubuntu virtual machines. Kubecontrol is the client we will use to verify both Kubernetes APIs. Finally, the makefile generates the cloud init configuration from an existing public SSH key so that later SSH-based installation and kubeconfig retrieval can run unattended. If the SSH key check fails, stop and create a key before processing. It is better to discover a missing prerequisite here than halfway through the VM installation. The makefile gives us a simple learning sequence. First, launch the virtual machines. Second, install K3s. Third, establish host access by fetching kubeconfigs and storing SSH tunnels. Finally, verify both nodes. One detail matters for the live demonstration. Each install K3s target already calls its matching kubeconfig target after K3s becomes ready. We can still show the kubeconfig commands separately when explaining the mechanism, but we should not imply that a second manual call is required. This distinction keeps the demonstration accurate and avoids making the workflow look more complicated than it is. We built the management cluster first because later workflows originate here. The app management target launches an Ubuntu 24.04 multipass VM named OK Management Local with the resources defined in the makefile. The install target connects over SSH, installs the pinned K3s version, disables traffic, adds the VM IP as a TLS subject alternative name, and waits until the node reports ready. At the end, it fetches the kubeconfig and starts the management tunnel on localhost port 6443. The node's management target gives us a concise proof that the management API is reachable from the Mac and that the node is healthy. Next, we repeat the infrastructure pattern for OK Infra Local. But we should emphasize that this is not a second node joining the management cluster. It is a completely separate K3s server with its own API, credentials, and lifecycle. The makefile uses the same VM resource defaults. It installs K3s with traffic disabled, waits for ready, then retrieves an independent kubeconfig. The local SSH tunnels terminates on port 6444 rather than 6443. So both APIs can remain accessible at the same time. The node's infra target confirms that our commands are now reaching the workload cluster rather than the management cluster. This slide explains the host access mechanism. Inside each VM, K3s listens on port 6443. On macOS, the makefile creates SSH tunnels so the APIs can be reached consistently from localhost. The management tunnel keeps port 6443. The infra tunnel maps local port 6444 to port 6443 inside OK infralocal. Each tunnel has its own generated kube config. This is why we can run commands against both clusters without changing the VM network. It is also why we must always be explicit about which kube config a command uses. In later crossplane work, the direct infralocal kube config serves a different purpose, but that distinction belongs in the next video. We finish with two commands that validate the complete result. Make status confirms that both multipass instances are running. Make nodes all executes the management and infra node checks with the respective tunnel kube configs. A successful result shows two independent nodes, each in ready state. That gives us three pieces of evidence. Both virtual machines are alive, both Kubernetes APIs are reachable, and the host is using the correct access path for each cluster. We stop here intentionally. Crossplane, Olama, and OpenWebUI belong in the second video, where the management cluster will deploy an application onto OK infralocal through the OpenKubes platform contract. Thanks for watching.